All right, guys, on first inspection, this one looked pretty easy, but after I looked at it for a little bit, it is very tricky. So congratulations to those of you that figured out a way to get to the answer. It may not be the way that I'm going to do it. I'm going to show you the way the book does it, and the book uses area for all of these. Okay? So the first thing the book does, it's going to find the area of triangle ABC. Then it's going to find the area of all the triangles that are formed when you join each of the vertices to the endpoints. Okay? So then we're going to find the area of triangle APB, the triangle of APC, and the triangle of BPC. Now, why is that? Well, because these three parts here all use the radius as their height. Okay, and yes, it's the orthocenter, it's the incenter, it's the centroid, it's the circumcenter, it's all of these. Okay, so the first thing I'm going to do is I'm going to look at this triangle. And I need to figure out how long this is. This is 4, this is 12. It is correct to assume that these two are congruent. So this side is divided into 2 equal parts. So AE squared will be 12 squared minus 4 squared. I'm doing the Pythagorean theorem, but I'm skipping a step. It would be AE squared plus 4 squared equals 12 squared. I just did one of the steps in my head. So AE is going to be the square root of 144 minus 16, which equals the square root of 128. I'm going to leave that there. Okay, now AE is also the height of the big triangle. So the area of my big triangle, triangle ABC, is 1/2 the base. My base is the entire length, 8, times the height, which is the square root of 128. And by the way, the square root of 128, the way you simplify this is you find the biggest perfect square that goes inside, and then you simplify that square root. So this becomes 8 times the square root of 2. So half of 8 is 4. 4 times 8 square roots of 2. That's 32 square roots of 2, or 30 radical 2. 32 radical 2. So that's the area of triangle ABC. Now I have to give myself more room. So I know that the area of triangle ABC is 32 square roots of 2, 32 radical 2, so the whole thing. Now what I'm going to do is find the triangle of the area of the smaller triangle. So let's start with triangle BPC. The base is 8, so it's 1/2 times 8, but the height is the radius, is what I don't know. Half of 8 is 4, so the area of this is 4R. Triangle APB, we're looking at this little one right here, is 1/2 times 12, because the base is AB, times R. And then triangle APC is the same because AC and AB are congruent, which means this is an isosceles triangle and the angles are bisected, so they're congruent. And they share a side. So I could do, I guess I could do side, side, side. But in case you don't see it. So these three added up have to equal this. So 4R plus 6R plus 6R equals 32 radical 2. So this is 16R, divide both sides by 16, 2 radical 2. So if you got this, congratulations. Again, you may not have done it the way the book does it. That was a very challenging problem, and I'm proud of you. If you didn't get it, hopefully you kind of can follow how the book solved it, and maybe you can come up with another way to do it. I know Matt talked about the fact that this little thing right here would be a kite. So he used a thought process there to figure out what R would be based on that fact that that is probably a kite. So there